Hello, this video is the introduction to how to solve a 3x3 system using a substitution method. Now, when we have three variables as opposed to two, and they are all to the first power, then we have a plane. And when we are solving a system of three such equations, then we're looking for the place where the three planes cross. And there are three possibilities. Number one is the planes will cross, and if they do cross, then there will be one solution, and we will know that there is one solution because we will find it. We will know what the x number is, the y number is, and the z number is. That's exactly the coordinate of a place where our planes crossed. And so we write the answer as x, y, z, because that's the location of the solution. The second possibility is the planes might be parallel, and so there will be no solution. And we will know that because when we solve it, we're going to get some kind of statement that is never true, like 5 is 10 or 8 is 4, whatever, something that is never true. Then we know that the planes are parallel and there is no solution. The third possibility is the planes might coincide, and if they do coincide, then we're going to get a statement that is always true, and we will have infinitely many solutions. If we come across one of these answers, then we have to write the answer in general form using the letters and expressions as opposed to just numbers, so that we can describe every possible solution. As opposed to just saying there is many, we have to actually show what kind of form they have, and that's what the general form of a solution is for. So in this example, let us use the substitution method to solve a system of three equations, three unknowns. And here it is. So when we use substitution method, we solve one of the equations, any one of these, for either x, y, or z, and use that information in the other two equations. Now, when we solve, it's easiest to solve for the letter that has no number in the front, because if we choose a letter with a number in the front, then at the end we have to divide by that number, and that almost always creates fractions, and then we will have to work with fractions all the way to the end, which is no problem. But why do fractions if you don't have to? So whenever possible, we can solve for something that has just one in front. So either y in the first or the z in the second. Let's solve for the z. So if we solve for the z in the second, that means we have to subtract 4x from both sides. So the z is 9 minus 4x, and then to cancel minus 2y, we add 2y to both sides, and that's our answer for the z. Now in the other two equations, we replace the z with what we just found it to be. So we copy the equations, and each time there was a z, we now use what it is, minus 3, then there is a z, is negative 4, and then the second equation is 3x plus 5y minus 2, z is 5. So the z is 9 minus 4x plus 2y, 9 minus 4x plus 2y. Now we simplify, and we will have two equations with only two unknowns. And that is similar to the questions we have solved in a different video. So let's simplify. Now we distribute the negative 3, so we have 2x plus y minus 27. Negative 3 and negative 4 is plus 12x. Negative 3 times 2 is minus 6y is negative 4. And then the second equation is 3x plus 5y minus 18 plus 8x minus 4y is 5. Now we combine like terms. So in the first equation, we have 2x plus 12x, that makes 14x. We have 1y minus 6y, that's negative 5y. And we move all the constants to the other side. So this number goes on the right side. We add 27 to both sides, plus 27, and that makes 23. The same procedure for the second equation. 3x plus 8x makes 11x. 5y minus 4y makes 1y. And then if we add 18 to both sides, we get 23. So that's the new equation, simplified version. Now, once again, we solve either one of these for the x or the y and use it in the second equation. So let's solve the second equation for the y. We minus from the 23, we minus 11x, and we use that information for the y in the first equation. That makes 14x minus 5 times 23 minus 11x is 23. Now multiplying through, 5 times 23 is negative 115. 5 times 11 is 55x is equal to 23. Now 14x and 55x is 69x, and if we add 115 to both sides, 23 plus 115 is 138, and to get x by itself we divide both sides by 69, and 138 divided by 69 is 138 divided by 69 is 2. So the x is 2. And that's our first coordinate. Then we need the other two. But we already know what y is. If we know the x, we can use that x here and figure out what the y is, which would be equal to 23 minus 2 times 11, that's 22. 23 minus 22 makes 1. So y happens to be 1. The only thing left to find is the z. But we have an expression for that as well in the beginning. So now we remember that the y is 1, the x is 2, and we use that information to get the z. So the z is 9 minus 4 times 2, that's 8, plus 2 times 1, that's 2. 9 minus 8 is 1, plus 2 makes 3. So z is 3. That's our last coordinate. And then we simply write our answer with as a point. So now our point is in 3 dimensions. It has 3 coordinates. And so the final answer is in the form x, y, z, which is x is 2, y is 1, z is 3. And this is the final answer to our question. And that's how to use the substitution method to solve a system of 3 equations with 3 unknowns. And if you have any questions on anything, please let me know. Thanks a lot for your time. Take care.